Well, hello again, grade 12s. I just wanted to sort of make instructions in a separate video for the Spring Lab. So I posted the Spring Lab on YouTube, and I'm sure you found that like so cool. Like I feel like a YouTube star now making these videos. Anyway, I wanted to post some instructions for you. So what I did here was I recorded the data. Okay, I'm going to post a link to the video in OneNote, so that when you go to OneNote, you'll see it there. But anyway, here's the data that was collected. You can see here I've written down the mass on one side and the stretch in the spring on the other side. So the mass is in grams, please notice that, and the stretch is in centimeters. Okay, and what I'd like you to do is not a full lab report, okay, but I would like you to do a couple of things. This is normally what we would have done. Normally I'd make you do a full lab report, but I mean, you know what, it's the pandemic, so let's take a break on full lab reports, okay? And let's instead, just so you get like the gist of it, like what was the point of this experiment? And the point is to determine the relationship. So let me tell you the purpose, okay? The purpose is to determine, okay, the relationship between force on the spring, which I'm just going to put Fs, and stretch, okay, in the spring. And your textbook for that variable uses x, okay, as the stretch. Okay, now basically to show you a diagram of the apparatus, just so you remember what it is that we were doing, I had this little ring stand like this. I had a spring hanging down from it. Actually, I'll use a different color for the spring. It's springtime. Let's use a rainbow colored spring, okay? And then what's happening is we attach a mass to it, okay? That's the mass. And then gravity will pull it down, okay? And then what'll happen is you'll get the difference between where the spring is unstretched to, let's say its new position is down here. So this is the rest position. We call it equilibrium because the forces are balanced. It doesn't seem to go anywhere at that point. And from the unstretched, this is unstretched up here, the spring. This distance from here to here is x. That's called the stretch. It's the change in length of the spring, basically. Okay. All right. So what's the relationship? Well, here's what I want you to do. Okay. So that's the purpose. What I would like here, let me write it like this, instructions. To my amazing students. Well, except for Deborah. And also Lara. How can I forget? Is to do this, okay? 1, draw a graph. Whoops. Draw a graph of the force on the spring versus x, the stretch in the spring, okay? Now, maybe this seems a little strange, but this x goes on the x-axis. You might think that it would be the dependent variable, but we're going to treat it as the independent variable, okay? I'll explain why later, okay? But please put that on the x-axis. Put this on the y-axis, please, Okay, so force on the spring versus X. Now just note, whoops, why am I having such a hard time? Note, force on the spring equals mg, where m is the mass, okay, on the spring, in kilograms, not grams. Notice I gave you the mass in grams up here, and the reason why I gave it to you in grams is because that's what I had in my hand. It was all measured in grams, so I just wrote it out that way. You have to divide those numbers by 1,000 first, then multiply by 9.8, okay? And then you have your data table. It's okay to leave X in centimeters, okay? So that's step one. Step two, determine the slope, okay? And the slope, like the maximum number of sig figs you should have in a slope like that kind of depends on what you use here, but these all have, let's say, 3 sig figs except for the first 2 values. So we'll go with 3. So I'm going to say 2, 3 sig figs, okay? All right, so that's step 2. Now, there was part 2 of the lab, okay? In part 1, okay, what we did in the lab was we determined the relationship. And you'll see when you draw the graph, you'll see the relationship. It's really simple. It's really obvious what's going to happen, okay? Like, I mean, once you draw the graph, you'll see, okay? It's a very straightforward relationship between force and stretch. You're going to determine the slope on that line segment that you'll see. And then what we'll do is part B depends on your result from the graph. So I'm going to come back and talk about part B. Part B is where we dropped a mass of 250 grams on an unstretched spring. Whoops. Okay, and so you'll see what happens there, and we need the result from part A in order for you to do part B. So I'd like you to do part A, and then we'll talk about part B in a separate video. All right, so we'll talk to you soon.